is Devonic. Today we are doing Lab 8, which is Schmitt triggers and voltage-controlled oscillators. So if we take a look at the circuit that we built in Part A, so this is just a subsection of it because eventually I'll talk about the circuit as a whole, but this right here is the voltage-controlled current source. Basically contains an operational amplifier, an NPN transistor. Here we have a potentiometer which allows us to control the input voltage, and this op-amp is controlled by is powered by a plus 15 volt power supply. Plus 15 volt power supply. So if we take a look at the IV characteristics of this current source, you can see that this graph represents the on the x-axis we have our voltage, on the y-axis we have our current. So as you can see, it decreases pretty linearly. So as we increase the input voltage, the output current decreases. Okay, moving on to the next part of our circuit, we developed a Schmitt trigger subcircuit which allowed us to measure the rail voltages. So here we have our Schmitt trigger. It's connected to some resistors. So this is our RF, this is our R1. So finally, we combined all the subcircuits together. So we combined our current source with our voltage, with our Schmitt trigger subcircuit. We can combine those two with a series of transistors. This right here, this has this little device right here. This chip right here has 4 transistors in it. So we have diodes, we have resistors, and basically, as you can see with the power supply, the op-amps are powered by a plus 15, minus 15 volt voltage, and the there's a substrate for the transistor device, which is a plus, which also needs a plus 15 volt input. In addition, we have a couple plus 5 volt inputs to power some other parts of the circuit. Okay, so here's our final VCO circuit with all the sub-circuits put together. We have our current source, our Schmitt trigger, our capacitor. Here's where our output of the VCO circuit is. If we take a look at the scope, we see that the output of the VCO circuit is a square wave, which ranges from negative V-rail to positive V-rail. And yes, essentially the voltage oscillates between those two values.